If you're just joining us, you can drop where you're from in the chat. We are doing our first Meetup for Argo hybrid style. We've got Ravi in Atlanta. Uh-oh, we got somebody from Salt Lake City, Dan. So Ravi's in Atlanta, eating some tacos and drinking some Modelo, and I'm out of Houston. And we're just streaming across the world apparently today, which is great. So I'm Sarah Davila. I lead field and partner marketing at CodeFresh, and I am joined by Ravi Lachhman. He is the field CTO over at Shipa. And before he joined Shipa, he was an evangelism leader, a chief architect at Harness. And I actually know Ravi from some of his previous sales and engineering roles at AppDynamics, Mesosphere, Red Hat, IBM. And he just really thrives at helping commercial and federal clients build that next generation of distributed systems. And which we do know from Ravi's background, he's got a love of travel and food, and particularly Korean barbecue. So if I'd known that, Ravi, I probably would have sent you barbecue versus tacos today. But you know, you do you. I'm going to stop talking. I'm going to turn this over to Ravi and let him just guide us through today's meetup.
Awesome. Yeah. Thank you, Sarah, for that introduction, and really happy to have everybody here on Cinco de Mayo, the 5th of May celebration. Let's see here. There we go. So I'll go ahead and skip who I am. Sarah did an introduction to me, minus 2 personal quirks. I never got anything right the first time. It took me a while to figure that out the older I've gotten. So if I got it right the first time, it's not right, you know, and this is why iteration is so important in software. I say that trial and error is software. And a lot of what we're doing with continuous delivery and GitOps supports that iteration, supports that safety. So when we get the right combination of things right, we're able to celebrate that in a safe manner. And so if there's any questions, I have the chat up. Keep it interactive. You know, I don't have to do this asynchronously. Synchronous is it's my favorite. So feel free to ask questions. So what are we going to be talking about today in today's meetup? Well, we're going to actually be talking about innovating a donut. So, you know, it is Cinco de Mayo. It should have been something more related, but I like talking about donuts. I like food. So we'll be innovating a donut here. So you're like, oh, this is a technology meetup. Well, you'll see where we're going with this. And then after we innovate a donut, we're going to be talking about, well, you know, what has codification and GitOps done for us, right? And so as things have shifted, continuously start to shift left, what does this mean? Give you a quick couple pillars of what GitOps is, right? If you're unfamiliar, if you're maybe one of your first times seeing this, and then talking about developer experience and how do you, from a platform engineering side, how do you abstract that? So talking a little bit about something called AAC, application as code. So it's a kind of a concept that my employer Shipa and a few other firms are kind of marching towards. And we'll talk about what that looks like in a little bit. So first thing we're going to be talking about here is DFNRS. So donut non-functional requirements, right? And so let's go ahead and let's just develop a donut. Like we're going to build some software. So, and so the first thing is, well, okay, so what we need to understand is when we're building a donut is this concept of what a policy is. And so basically there's policies out there that really, like if you look at the Wikipedia definition of a policy, it's some sort of statement or some sort of procedure that equates to a rational outcome. So a policy might be in the technology world, you know what, the author can't be the publisher of an artifact, or the author can't deploy, right? So there's business controls and policies because there's a rational reason why you can't have that type of access. Or let's say that in our particular case here, we're going to make a new policy that every donut needs to have rosé in the top, right? So let's talk about this policy. So if anybody, this is a real picture. This is from a place in Denver called Habitat or Habit Donuts. They're known for putting liquor on top of donuts. And so this is their rosé donut, right? And so let's say that we were employees of Habit Donuts, and you know, we have a policy in place that we actually need to put rosé on top of our donuts, right? So there's a few ways that we can actually execute this. And so the first way, there's two types of ways of looking at enforcing something, right? Or actually delivering something. So there's this comparison between something being declarative versus something being imperative. And so what does the first thing mean? So if we want something to be declarative, right, it's like we should have rosé on top of our donuts, right? So being declarative means you talk about the end state, you don't talk about any of the intermediary or boundary steps that you need to execute. So if you're seeing this in Kubernetes land, they typically use pepperoni pizzas a lot in the example. Like, I would like a pepperoni pizza, so it has to have pepperoni on top, right? So that'll be a declarative type of policy versus an imperative. So let's talk about the flip side, an imperative policy. So imperative, you have to get into the nitty-gritty of everything. You have to be very specific with the steps. Nothing is inferred. And so this eye chart here of what it takes to make a donut. You have to prototype it, make the donut, check the suppliers, eggs, flour, sugar, rosé, get a liquor license. I mean, all this stuff until you kind of put them on the shelf at some point, right? And even those have like substeps. This is just a subset of what I could think of what a donut would need. But this is more imperative, right? Like, a lot of times when you build a policy, and a lot of the policies are very imperative, like XYZ had to happen in this order before something failed, or like you have to be very, very explicit. And so now that we're kind of out of donut land here, let's talk about, okay, so we know what declarative is, we know what imperative is, and this is actually going to be quite important when we get into GitOps, because GitOps is a declarative based approach. And so the first thing to consider is there's this tool called Kubernetes. They call it the mighty Kubernetes. If you're familiar with Kubernetes, you can see a deployment YAML on the right. And Kubernetes did a lot, right? Like, if you kind of take it back, like, so Kubernetes has been out since it hit GitHub in June of 2014. But if depending when you adopted or first saw it, it might just be a couple of years ago. If you can jog your memory, a time before Kubernetes, there was, everyone spoke different languages, right? I could give another set of slides of like, hey, this is what it looked like before Kubernetes. Basically what Kubernetes gave us is a declarative approach, right? So if you hear Kubernetes is a declarative system, this is exactly what it is. If you look at what I'm declaring on the right here, oh, I need one replica of something, or oh, hey, this is exactly this is about what I need. Kubernetes go off and ferret what I need, right? And so that means that both the development team and the operations team, at least they can speak same YAML. Now that might get into, there's a whole intrinsic discussion of if that's the right approach and how you disseminate expertise and all that stuff. But being Cinco de Mayo, I'll spare that part of the explanation. And so let's first talk about, what is a GitOps? I was committing into a directory, into a repository, a bunch of pictures of a Siberian Husky. So I had the commit change there. When I hit commit, this better go to prod, right? But basically the inception of GitOps is source control, right? So there's get is in the name of GitOps. So from a software engineering perspective, a lot of times how you notify that you're done with work is you commit something typically, right? Like, okay, I'm ready to like more than one person see this. Unless you're like me and you incessantly save stuff, like, oh, in case like my laptop blows up. But usually when you commit, it's indicating to the world that you're ready to kind of share with another person, another team, or it's ready to go to the wild. And so with GitOps, the genesis of that is actually source control. Now, there's very stringent and non-stringent definitions of GitOps, like anything. Like, for example, microservices, it's a paradigm. If you were to follow the textbook definition, everybody has a copy of the data. It's using messaging, and you have certain transaction boundaries you don't cross. Like, it can be very in the minutia, but overall, GitOps as a paradigm, it has to do with kind of the genesis of it. It's like source control event. And so there are these key pillars of GitOps, right? And so like, okay, so the kind of the first thing is, well, everything needs to be declarative. So WeaveWorks 5 years ago, in 2017, came up with like this definitive GitOps manifesto, and they had basically four pillars that they talked about. And so the first one being, well, everything is declarative. So we know what declarative means now, right? Like, I want a rosé donut. So with everything being declarative, a couple things are kind of inferred with that. So the first thing would be, okay, if everything is declarative, and that means that the state that I need, or the canonical state, is stored in source control. So here, since it's GitOps again, they say it should be stored in get, but potentially you can apply GitOps principles in anything, per force, CVS code case, pick your SCM of choice, right? CVS, SCN, and whatnot. So, but basically what you're declaring is stored in source control. Kind of the second or the third or fourth, you're reading left to right like I am. Well, if this is more so for like the workflow, like what GitOps represents. So if something is approved, right, if it passes the test, it should be applied automatically. So in Kubernetes land, if you pass your test, or the YAML, like even lower level, if the YAML was compliant, go for it. kubectlf apply, have at it. It should be applied in the system. And then also there's this concept of auto healing or reconciliation. So with GitOps engines such as Argo, or most GitOps projects have this particular paradigm that they implement, that if there's a difference between what is declared. So for example, let's say in my Kubernetes spec, I want 2 replicas, and then Sarah goes into the cluster and modifies that spec directly and says, oh, you get 3. The reconciliation or auto healing will say, oh, well, what was wanted was 2. So the state has changed, so go back and change the number of replicas to 2. Like that's one example, actually one of the more key examples of auto healing. But that's typically GitOps in a nutshell. And so let's talk about something else. Okay, so now being an Argo meetup, you might be preaching to the choir, like, okay, yeah, that's pretty rudimentary stuff. But let's talk about another kind of like intrinsic problem, right? I call it the feeding problem. And so let's talk. So it all boils down to what on earth do you give Argo? What do you give it? What do you give Flux? And so there's kind of like this interesting divide that's kind of happening in the software engineering field. It's like this divide of like platform engineering versus software engineering. This can date back to years gone by, the cats and dogs, dev versus ops, and so on and so on. But there's this kind of a movement that a couple of companies have made popular. So that book company in South Lake Union in Seattle, and that movie company in Los Gatos, in the Bay Area, they made popular something called being a full lifecycle engineer. And so what that means is that if you write it, you run it, or you build what you operate, right? Like, who best to know the feature and how it runs than the person who wrote it, right? Or the engineer who wrote it. Well, there's a lot that's very loaded to say that, but to kind of like support that these days, like let's say that you were looking a lot, smelling and looking, looks like a duck, smells like a duck, could be a chicken. I don't know how that saying goes, but if you were marching towards that paradigm, right? Like what you'll start running into from a skill set perspective would be, oh, well, my background is software engineering. So like, it's like, oh, I know that I wrote a feature that was compliant. So compliant being I passed quality code coverage, stylistic type of things, like, hey, I'm not, if I passed all my Sonar Cube tests, I got a B-, good enough, from the team, and stylistic changes or stylistic checks and whatnot. But personally, I'm not a kernel engineer, right? Like Linux kernel, it's be the furthest thing away. I don't really care, where it's running. And if you kind of look at like a lot of the Kubernetes centric tools, like take, kind of clicking in, like kind of past like the CD stack, but like very, very, very Kubernetes centric things like, hey, you know what, we do logging with eBPF, right? Like, hey, that's core to the kernel. I'm not sure how, like, I don't know how to configure that. It's beyond me. But also like certain things from an engineering perspective is that, oh, well, I know that the application has traffic coming in and traffic coming out, so ingress and egress. I might not be a networking engineer, so I might not be able to tell you like, oh, well, I know that my application can only talk to another application and it should receive traffic from somebody else. But how do I implement and enforce that is beyond me. Like, I'm not a networking engineer. I couldn't tell you how to set that up with Istio or Trafic or Nginx, right? Like, I'm not, not that good. And then also, oddly enough to say, like, as a software engineer, I think that Kubernetes is implementation detail. That, okay, our external customers, they don't care where stuff is run. They can run, we could be running on a mainframe using LPARs for all they care. But who does care? Or let's say I'm talking personify a platform engineer. Your internal customers as a platform engineer does care, right? Like the software engineer does have to care because it affects how they go to production, or affects if they have to build anything specifically. Going to Kubernetes, who's authoring your YAMLs, right? Or are you provided a Helm chart to kind of fill out? And then for a platform engineer to kind of like produce their functionality, so kind of the shifting role of a platform engineer, he or she or the team, they're more in charge of making sure that there's capacity in, let's say, Kubernetes clusters, and also tooling to onboard and offboard workloads, right? So they're in charge of that. But for them to achieve that, you can see this like eye chart again on the right, like, oh, we need to use a GitOps engine, we need to use a service mesh, we have to have some sort of like OPA based approach, or like or some policy based approach like OPA, and we need to provide like a observability framework, like something like Fluentd or Prometheus, and manage all these clusters with like Rancher, right? Like their stack is growing, 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 and so it's like, how much of that do they expose? Because from a software engineering perspective, what are you subject to? Actually, I ran into this problem today on Cinco de Mayo. We have an open source project that we're trying to get into the Cloud Native Compute Foundation. And so part of their feedback and the submission package was, hey, we're a little bit confused, like what happened after the PR? Like there's a lot of like things that happen on our GitHub actions, like a lot of like checks. And I'm like, oh, yeah, we didn't really explain that to anybody, right? Like, and so we're going back and like creating a bunch of documentation and the contributors guide and whatnot for that. But taking open source out of the picture for that, it's, let's say for folks here, like let's say it was your first week on the job, right? So I'll always pick on Sarah because you work with her. Like, let's say Sarah's my boss and it's like I just got hired, I don't know, Code Fresh or something, like as my first week on the job, and so like it's like, oh, like yeah, I need to like deploy, I need to get a feature out there. Well, what am I subject to, right? Like how do I know as a software engineer the totality of the quality steps or the confidence building exercises that's needed? This is a funny thing I remember seeing it in a history book in the 80s. It took me a while to find this picture. I'm old, so I'm like, oh yeah, I remember reading this like in like middle school. But this is actually from Texas, Texas-based book. How many regulations does it take to make a hamburger? And it's 41,000. That was like the going joke from, you could read that here. But, at jokes aside, like how many rules and policies am I subject to get my idea into production? I passed the code coverage. I passed the integration test. What other tests do I need to do every time I add a non-functional requirement? So that, that DNFR, donut non-functional requirement, all jokes aside, like, hey, networking wasn't part of like what I talked about. It's a non-functional requirement of the app. It's not like adding two numbers together. It's how it communicates. What, like, you keep adding these additive policies. So there's a concept I call the kind of the fog of development, that you kind of lose. It's a situational awareness. It's from the fog of war. You kind of lose situational awareness. And so like my ramp time in Sarah's team, she might be like, Ravi, you got a week to do this. You like completed like a quarter of your story points. Like, what's going on? It's like, Sarah, it's Cinco de Mayo, but no, it's like, it takes a while to ramp up, right? And just figure that stuff out. And by the time you figure it all out, changing teams, right? And then that intrinsic knowledge goes away. And so what that boils into, I should change the slides. They're behind me for people in the room. They can see what's coming up next, but I can see the big screen for the virtual folks. Is that, hey, basically having all these regulations or like policies that you like really don't know about, this 41,000 regulation thing, it just drags out your deployment process, right? Like, until you figure out like all the changes that you need, like, oh, you can kind of go left to right. We have to make a branching strategy. We have to document the changes. We have to enrich our configurations. We have to deploy into several environments to run confidence building tests on them. We have to validate. So if you have to, someone has to sign off, or a system has to sign off. It keeps going, 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 and you just don't know like the next step, but you keep pushing, and that's become difficult, right? Like, what are the policies? Who owns that? Why does more than one team have their hand in the cookie jar? And you're just dragging out your deployment process. You can have, the most sophisticated GitOps engine in the world, click to deploy, but if you don't really know what's going on, because our open source project, everything's done pretty quickly. We have about like a whole battery test that run, spins up a cluster, Kubernetes cluster, spins it down. It does very sophisticated stuff, but we're running into that people don't know, like, hey, what exactly is going on? They look at very lengthy, like GitHub actions, configurations to kind of see that. And it's like, oh, it's very lengthy, but it could be anything, right? It can be using something like Argo, or you can be using another CD tool, and it's just a perception thing. And so this gets into the feeding problem, right? So, all these food related things, kind of coming to this point, right? Like, what exactly are you giving Argo, right? Like, what you giving it? So if you kind of look at what you're feeding your GitOps engine, it can be a lot of things, right? Like, I'll play both sides. I'll play platform engineer and software engineer. Commonly, you might be feeding it a lot of Kubernetes manifests, or you might be feeding it something like a Helm chart or Helm templates, multiple Helm templates. Like, hey, just fill out these values YAML and good to go. But you're still having to fill out multiple things. Like, not only internally at Shipa, we use Helm and Kustomize, right? Like, and so, not only are we writing environmental specific things in Helm, we have multiple environments, so we write overlays and Kustomize for that. And so these are all things that are going into the CD stack. And even more so, every time we add another service or we have to make changes in Rego, we're adding our OPA. This list can go on, right? It could be anything we're feeding it. One of my friends, I showed them a copy of this slide and said, "Oh, well, because the logo has a helmet, this is why I can't eat." I'm like, "Oh, I get it now." But I know it's a kind of an intrinsic problem, right? Like, what are you, feeding your GitOps engine? I remember as a joke, a couple days ago on Twitter, I forget who the guy was, but he said that the truth be told, he's never written a YAML by hand. He's always copy and pasted from somewhere. He called it the Genesis YAML, or the primordial YAML. Since the start of their company, they've just been adding to it. But similar thing, right? Like, how do you feed the machine? And so I kind of talk about the approach that we, at Shipa, what bodes really well with the GitOps model is something called application as code. And so our sole purpose is to reduce lines of code or lines of YAML that your developers have to write. So the feeding problem, it's kind of goes away for the most part. And so let's talk about what a Shipa framework is, or what a particular framework is. And so basically these DNFR, donuts, non-functional requirements, or let's drop the D part. So your non-functional requirements of an application. These are kind of get stapled on top of, let's say we're making a calculator, so we know, we have to add two numbers together. That's the functional requirement. Non-functional requirements would be like, hey, we're calculator.com, so we need to be able to take traffic. Calculator.com saves all of what you do like a scientific calculator. So, we need to be able to write to certain places, and also in case more people come to our calculator, we need to scale it, right? And also it should be secure. And so coming up with kind of a list of plain English terms, which I'll show you how to execute that in Argo in about 2 or 3 minutes. It's basically what Shipa we're hyper focused on, so it can help alleviate the feeding problem. And also, another intrinsic question or portion here is, well, what is an application, right? It goes back to the story. If a tree falls in the woods and no one was there to hear it, did it make a sound? Or I heard ones with bears, or, and other stuff, but not maybe appropriate for Cinco de Mayo. But what is an application, right? And so, well, is it something in your config management database? Is it something that ITIL said? Is it a Helm chart? Is it an image, right? And these type of questions. And so what we say in application. Actually, I was giving a talk today at PlatformCon. So what we define an application as is, hey, it's source code or sort of images, it has an address and a team and whatnot. But that don't want to get too much of minutia of what Shipa is. So basically this is it, right? What all of that we kind of work towards here is what I like to call the one-line developer experience. I was lying to people. It was actually 2 lines. I forgot line 7. So I was lying about 50%. But from a developer experience standpoint, when leveraging an abstraction layer with your GitOps, with your GitOps layer, all you have to feed a developer, or all the developer has to feed, is like an image and what a Shipa abstraction is, and that's it. This is actually crossplane that we're using here, so that is the end goal. So let me jump into let me just double check if there's any questions or whatnot coming in. So, all right, no questions. So I have one screen in the TV behind me, so I gotta see what screen stuff comes in. So let's see here. So. This thing. Can everybody see GitHub? Just make sure to paint it correctly for people who are. Okay, cool. Looks like the folks in here can't see it, but I'll explain to them. So going back to what we were looking at on the previous slide, let me see if I can't mirror the displays. So I hope this worked. Can the people online still see GitHub? It worked. Oh, it's behind me too. Okay.
You're good.
Oh, perfect. Yeah. the new MacBook has like a little bar I can press. So first time it smiled at me. So going back to what we were looking at on the previous slide, all we have to do is feed our GitOps Engine an image name, right? And a Shipa abstraction, and that's it. I've executed this kind of like ahead of time in ArgoCD. So let me kind of unpack how I got to this state, right? And so also I executed it in GitHub Actions, but this is Argo Meetup, you know, focus back on Argo here for y'all. So kind of like, you know, the going back to the end goal of this, like let me unpack how that was created, right? And so a couple of pieces, yeah, I don't have a whiteboard here, but the kind of the main integration piece that links this together is also a project called Crossplane. So not sure, despite like round of like folks, like not sure how many folks have heard of Crossplane. It's a Kubernetes centric way of managing a Kubernetes centric way of managing non-Kubernetes resources. There we go. I got the combination right. So that's something we use pretty frequently. We're actually a Crossplane provider at Shipa. I didn't write the Crossplane provider, but some of my friends here did. And that's kind of like the magic glue. And so let me kind of step into Shipa really quickly. So boop, boop, boop. And so going back to those like those facets of, you know, how did we get to, I have to move all these pointers around. How did we get to this? How did we build that? Well, kind of building a quick abstraction that can be executed by Argo here is this concept of frameworks from Shipa. And so we also have an open source project called Catch. This is just more of the productized version. This is the free version that I'm running here at Shipa. But also everything that I do here can be accomplished with infrastructure as code. So I actually set all this up ahead of time using Terraform. So this is actually what set up the demo here with all of the particular Shipa objects. So I just like to use UI to show our friends here. Let's see here. So let me just modify one of these. And so basically like what Shipa provides or open source project Catch provides, it's this kind of like 9-prong approach on what does your application need, right? Like what am I going to feed my GitOps engine, or what am I going to feed a CD solution? Kind of the first thing would be, okay, like I'm going to play platform engineer currently. So the first thing is like, okay, from a developer experience standpoint, like again, I see 1 or 2 folks like jumping on currently. We're only feeding, the developer's only feeding an image and the name of this framework, and then Shipa will kind of take care of the underlying wirings for you, basically writing the CRDs and the necessary Kubernetes manifest and objects on your behalf for a developer. So first thing would be, okay, given, let's say we're a tier 2 application here at cincodeMayo.com, or you know, Habit Donuts, for those who caught the earlier examples, we might say, you know what, for a tier 2 application, we need to put resource limits on it. So this is your the resource spec, the limits and requests. We might say, you know what, we only give 8 gigs of memory, 100 CPU shares, and disable swap. Kind of secondary, like, you know, when you're deploying towards this abstraction would be, oh, well, who has access to deploy through this? I know, depending on what GitOps engine you're using, you know, some of this might be optional. So we, you know, with Shipa also, it's just one opinion on, well, how do we provide RBAC access to the abstraction layer? Kind of the auto scaling. This might be, you know what, this wouldn't replace something like a cluster level autoscaler. So like you need to add nodes, but from an HPA horizontal pod autoscaler perspective, you might say, you know what, anybody who deploys a tier 2 application, we're using Kubernetes to give them, you know, something else. So for a tier 2 app, fine, HPA, so I can replace something like AWS Carpenter. From registry controls, so you might have certain policies that we can only pull from certain repositories. Again, you know, I'm more familiar with AWS, but it might be that, you know, your arn.ecr.aws.com, your ARN would be your Amazon resource ID, right? Like for your specific team, you're only able to pull images from a certain repository or a list of repositories. Application control, this would be taints and tolerations. So if you have to pin a workload, right, like somewhere, Shipa can help you pin it if you have a Windows workload. My personal favorite is network policy. Going back to a developer, I do not know anything about networking. People always assume I have a really cool home network. I don't. I use a mesh. Click, 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 it's done in the house. My biggest production outage was networking related. I misconfigured networking policy on Kubernetes and I blocked half the internet for like 4 hours from our servers. With Shipa, it's very easy to configure networking policy. So, going back to the feeding, got the feed Istio CRD and Istio configuration. To GitOps Engine, no, you can do it in plain English. Here, say I was codefresh.com, right? So let's say I was codefresh.com. Clearly on our .com site, you need to allow all the traffic, but let's say you have, Codefresh SaaS, like app.codefresh.com. You might say that, oh, you know what? We're only allowing traffic from our authentication service or something to kind of flow in. Now, I don't have one called authentication. Bear with me here. I'll just pick easy deploy.js, like pretend that was your authentication service. Kind of like last little itty bitty pieces here with Shipa is that, we ship with CoreOS's Claire project. If you don't have a solution in place, most people do at this point. And kind of like last two, if you need to create a persistent volume claim or a PVC, like, every one of our pods have to have var lib MySQL. If you're using MySQL there, you can quickly add that here. And, kind of a piece, this is pretty Shipa specific, so I won't touch on it too much. Like, it's if you're not deploying through Shipa, right? Shipa has this ability to visualize running Kubernetes applications in terms of what developers need. It's funny, the founder and I have very similar backgrounds. We came from very development-centric backgrounds and were forced into Kubernetes. But that was why actually where the company started. But kind of with that, I know went a little fast there for the meetup, but love to open up the questions. We can talk about Cinco de Mayo. We can talk about kind of developer abstractions, developer experience, how do you measure it and whatnot. But that's at least from my one-sided conversation. Definitely open it up to the floor, or open up for folks. Or any questions in the room, don't be shy.